I am Siti Najiha binti Muhammad with matric numbers 201751. So this time, I have received an assignment for ESC 4513 Bioremediation, in which we are required to build a bioremediation model based on the bioremediation method. So the method that I have chosen is Bioventing. So what is Bioventing? Bioventing is an in situ remediation technology that uses microorganisms to biodegrade organic constituents adsorbed on soils in the unsaturated zone. So, in bioventing, amendments are made by adding nutrients and moisture to enhance bioremediation, with the ultimate goal being to achieve microbial transformation of pollutants to a harmless state. So during bioventing, oxygen may be supplied through direct air injection into residual contamination in soil. So bioventing primarily assists in the degradation of adsorbed fuel residuals, but also assists in the degradation of volatile organic compounds (VOCs) as vapors move slowly through biologically active soil. Bioventing uses low airflow rates to provide only enough oxygen to sustain microbial activity, and oxygen is most commonly supplied through direct air injection into residual contamination in soil. So bioventing is also applicable to any chemical that can be aerobically biodegraded. So techniques have been successfully used to remediate soils contaminated by petroleum hydrocarbons, non-chlorinated solvents, some pesticides, wood preservative, and other organic chemicals. So the criteria need for successful bioventing. To carry out a successful bioventing, there are two basic criteria that have to be satisfied. The first one is air must be able to flow through the soil in sufficient quantities to maintain aerobic conditions. Other than that, natural hydrocarbon degrading microorganisms must be present in large concentrations to obtain reasonable biodegradation rates. So there are a few aspects that influence bioventing feasibility, include site geology, soil moisture and microbial activity, and the nature of the contamination. So these factors are assessed via three primary physical parameters, which are functions of soil structure, particle size, and moisture content. There are a few requirements that are needed in designing the bioventing system. So the first one is design radius of influence, or ROI. It is an estimate of the maximum distance from a vapor extraction well or injection well at which sufficient airflow can be induced to sustain acceptable degradation rates. Next is wellhead pressure. So wellhead pressure is the pressure or vacuum that is required at the top of the vent well to produce the desired induced airstream flow from the well. Other than that is induced vapor flow rate. So induced vapor flow rate is the volumetric flow rate of soil vapor that will be induced by each extraction or injection well and establish the oxygen delivery rate to the in situ treatment area. And next is initial constituents vapor concentrations. In initial constituent vapor concentration, it can be measured during pilot studies or estimated from soil gas samples or soil samples. So they are used to estimate constituent mass extraction rate to determine whether treatment of extracted vapors will be required prior to atmospheric discharge or reinjection. Then we have required final constituents concentrations. So this aspect, the required final constituent concentration in soils or vapors are either defined by state regulations as remedial action levels or determined on a site-specific basis using transport modeling and risk assessment. So the next one is required remedial cleanup time. So this aspect are influenced the design of the system. So the designer may vary the well spacing to speed remediation to meet cleanup deadlines. Other than that is soil volume to be treated. So this element is determined by state action levels or a site-specific risk assessment using site characterization data for the sites. So pore volume calculations used along with extraction flow rate to determine the pore volume exchange rate and oxygen delivery rate. And apart from that is discharge limitations and monitoring requirements. So these elements are usually released by the state air quality regulations. Site construction limitations such as buildings, utilities, buried objects, and residents must be identified and considered in the design process. The last one is nutrient formulation and delivery rate, which can be established through either field or laboratory pilot studies. In evaluating the effectiveness of bioventing, there are a few aspects that we need to be considered. First is the initial screening of bioventing, the detailed evaluation, the evaluations of bioventing system design, and the evaluations of bioventing system operation and monitoring plans. First of all, we have to do the initial screening of bioventing effectiveness. This section defines the key factors that should be used to decide whether bioventing has the potential to be effective at a particular site. We have to determine the types of soil that present in the contaminated area. Bioventing is not likely to be effective if the soil targeted for remediation is clay. After that, once we have completed the initial screening and determined the bioventing may be effective for the soil and petroleum product present, review the CAP further to reconfirm effectiveness. Next, the detailed evaluation. The detailed evaluation should consider a broader range of site and constituent characteristics. For example, intrinsic permeability, soil structure and stratification, microbial presence, soil pH, moisture content, nutrient concentration, and depth of the groundwater. For constituents characteristics include chemical structure, concentrations and toxicity, vapor pressure, product composition and boiling point, and Henry's law constant. Apart from that is evaluation of bioventing system design. We have to determine the design elements and identify and review the conceptual process flow design and the system components. Next is evaluation of bioventing system operation and monitoring plans, which allow us to determine whether start-up and long-term system operation monitoring is of sufficient scope and frequency, and whether remedial progress monitoring plans are appropriate. So, the situation or problem. The situation or problem that I have chose is that there was a major diesel spill from a fuel line near a railway. So immediate cleanup is necessary. So I choose Bioventing because it has the ability to reduce a wide range of petrochemical compounds aerobically. And apart from that, Bioventing has been proven to be very effective in remediating releases of petroleum products, including diesel fuel. So it is suitable for me to choose Bioventing as the bioremediation method of the diesel spill. So for the site characteristics, so the soil type of the contaminated site is fine grained soil. So there is a microorganisms, primarily bacteria and fungi. So the soil pH is 8 and the temperature is 25 degrees Celsius. So there are a few advantages of Bioventing. The first one is the equipment is easy to install and it creates minimal disturbances to the site operations, and this method requires short treatment times that usually take between 6 to 2 years, depends on the optimal conditions. However, this treatment also have its disadvantages, which are not applicable for certain site conditions. For example, sites that have low soil permeabilities, which are high in clay content, and this method also cannot always achieve very low cleanup standards. So this is my model in which the white one and the black one represent the pipes that supply the airflow to the contaminated soil, and as you can see here, this is the nutrient tank and this is the UST. UST is the underground storage tank. This is the blower and this is the vapor treatment, and this is for atmospheric discharge. The nutrient tank is actually optional depending on the type of soil that we want to remediate. Last but not least, Bioventing has been used to remediate sites since the early to mid-1980s and is becoming more common. Most of needed equipment is readily available. It is likely that the use of in-situ bioventing will become more attractive to the remediation community, particularly its use in conjunction with soil vapor extraction. In the mid-1990s, soil venting vendors began to monitor bioventing degradation, design venting systems, and optimize biodegradation. Bioventing technology employs relatively low airflow rates, which not only provides the oxygen required for biodegradation to occur, but also minimize the volatilization and release of contaminants to the atmospheres. Thank you for watching. Hope that this video will give you more information and understanding on how bioventing system works in remediate the contaminated soil. Bye for now.